Hello everyone, this is Shruti Saxena Das, and in today's video we are going to discuss about Huffman encoding. It's a compression algorithm which is used in the presentation layer of OSI model. Now here in this algorithm, each symbol is given a certain code. Now what is a symbol? Suppose you want to compress a particular word. Let's say we are taking a word submission. Okay. Now in this word, each character will be your symbol. So S is a symbol. Then you have to consider only unique symbols like S, U, B, M, I. Now see, again S is repeating. So here we are not going to consider S again. Again S is repeating, then I is also repeating. We are not going to consider these three characters. After that O and then N. So each character is a symbol. Now what we have to do in this case, basically what we do that we assign less number of bits to symbols that occurs frequently. Like in this case, S is occurring frequently and I is also occurring frequently, so we can give less number of bits to these symbols S and I, and more bits to the symbols which occur less frequently like U, B, M, N. All these symbols are not occurring frequently, so we can use more number of bits to represent it. So that is the concept of Huffman encoding, that each symbol gets a certain code. Each symbol gets a certain code. And on what basis we have to provide these codes? According to the number of occurrences. So in this case, you can see like we have discussed about this example, that if you want to compress this particular word which consists of a symbol, so each symbol is each character. Now here you need to find out the frequency of occurrences of each symbol. So for S, frequency is 3. For I, frequency is 2. So what we have to do, if any symbol is occurring more frequently, then we have to use less number of bits to represent it. Okay. Now in Huffman encoding, basically there are two phases. In the first phase, we have to build a Huffman tree. So we have to build a Huffman tree from the input characters. Like in the above case, in submission, what are the inputs? Inputs you have to take in alphabetical order. So we are having B, then we are having I, then we are having M, N, then S, M, N, O, and then S. Okay, so these symbols are there. So first phase will be that we need to create a Huffman tree from these symbols. The second phase will be that we have to traverse the Huffman tree, which we'll create, and assign codes to the characters. Okay. Now these will be the two phases in Huffman algorithm. The first one will be to create a Huffman tree. The second one is to traverse a Huffman tree and then assign codes. So algorithm will be as follows. It is written on the sheet. So we'll discuss the algorithm and then we'll move to the example. Now you can see it over here. Okay. You can see it over here. See, the input to the algorithm will be the array of unique characters. Like in case of submission, it will be, like I said, it will be B, I, M, N, O, S, and U. So you need to provide unique characters, and along with the characters you have to give the frequency of occurrences, how many times that particular symbol is occurring in the string. Okay, and output will be Huffman tree. Now how will we create a Huffman tree, the first step is that we need to build a minimum heap. Now, what is a minimum heap? Minimum heap is a binary tree. Binary tree, you must be knowing about binary tree, that it's a tree with at most 2 children. Okay, you can have one right and one left child node. So at most, that means any tree can have a root node with 1 child or 0 child or 2 child. Okay, so minimum heap is a binary tree such that the data contained in each node is less than or equals to the data in the child node. Okay, so first step is we need to build a minimum heap of all leaf nodes. Second step will be, after building minimum heap, we need to extract 2 nodes with the minimum frequency. So you need to consider all the nodes and you have to extract the 2 nodes with the minimum frequency among them. Then the third point says that we need to create an internal node. How? That, see, we are extracting, in the second step, we are extracting 2 nodes with minimum frequency. Now you have to sum up the frequency of these 2 nodes, and then the resultant node will be your internal node. Okay, so it will be equals to the sum of the 2 nodes frequencies. Now mark the first extracted node will be marked as the left child, and the second extracted node will be marked as the right child. We have to repeat these steps until the heap contains only single node. Okay, let us discuss it with the help of the example. Suppose we are going to take certain symbols, and along with these symbols we are going to take the frequencies. Okay, so suppose that certain symbols are given. So symbols are A, B, C, D and E. There are 5 symbols which are given, and the frequency given is, okay, frequency given is 6, 8, 10, 12, 18. So first step says that we need to create a leaf node for each unique character. All these are unique characters, okay, and we need to create leaf nodes. All these are leaf nodes, that means they themselves are trees. Okay, basically each node here represents root of the tree with a single node. Okay, A is a tree with a single node A. This is also a tree with a single node B. This is also a tree with single node C. Likewise D and E. So you need to remember here that in the first step what we did, we have created leaf node for each unique characters. Okay, and we need to build a minimum heap of all leaf nodes. Okay, minimum heap means, see here, minimum heap means you have to arrange it in a, see, symbols must be given, but here I have arranged it in ascending order. So I have created a minimum heap like this, A, B, C, D, E. This is the order. Now the second, A is 6, B is 8, C is 10, 12 and 18. So this is the first step in which we have each node representing root of a tree with a single node, and secondly a minimum heap for all leaf nodes is created. Okay, 6, 8, 10, 12, 18. In the second step, we need to extract 2 nodes with minimum frequencies. So we can see that minimum frequencies means 6 and 8, these two, A and B. Okay, we need to extract A and B. Now see the third step, we need to create a new internal node with a frequency equal to the sum of 2 node frequencies. That means we need to extract these nodes. We have extracted A and B. This is 6, this is 8. We'll sum up their frequencies. Now 6 plus 8 will be 14. and this will be our new internal node. So the first node which you have extracted will become the left node. The second node which you are going to extract will become the right node. Okay, and this will become an internal node with the frequency of occurrence as 14. So now you have seen that these two you have extracted. You are having C with 10, D with 12, E with 18. Again we need to construct a minimum heap. So this is 14, so that means this should be inserted over here. Okay, between 12 and 18. So now the heap will be C, D, then your internal node whose frequency is 14, and E. The frequency of E is 18. Fine. Now the next step says that you need to extract, again we have to repeat the same steps. So we need to extract the two nodes with the minimum frequency. Now here the minimum frequency among C, D, internal node, and E is 10 and 12. Okay, so we'll extract these two nodes. So these two nodes are, first extracted node will become left node and next will become right node. We'll sum up their frequencies. 10 plus 12, you'll get 22. Now again this will become new internal node. Okay, so from minimum heap, these two we have extracted. So these two we have to take out and we have to insert this new internal node. So already one internal node is there with 14. E is having 18. Now this one is 22. You have to maintain the property of minimum heap. So you have to insert it in the proper place. You cannot insert it here. Okay, you cannot write 22, 14, 18. You have to maintain the rule of minimum heap. So you have to write it in ascending order only. So you'll be having 14, E is 18, and new internal node which is 22. Fine. Now in the next step, again you see that we have to extract two nodes with the minimum frequencies. So we'll extract 14 and 18. So it will be, see now this internal node which is 14, we can replace it like this. Okay, both are same. We have represented this internal node means this thing. Okay, so this will become your left. The first extracted value will become your left child. Okay, so this will become your left child, and in right E will come. Fine. So E is 18. Here you are having 14. 14 plus 18 will be 32. Yes, 32. Fine. Now see, again we have added the frequencies of these two. We got 32, and this internal node with the frequency 32 should be added in the minimum heap. Now you can see that these two we have extracted. Now only internal node with 22 value was left. So 22 and after that 32. So one internal node whose value is 22 is left, and the new internal node with the value 32 is there. Okay. Now again we have to extract the two nodes with minimum values. Now only two are left, so we are going to extract these two. So in the next step, this will be the result. This will be the result. Now in the left what should come? Internal node with value 22. That means this thing should come. Okay, so 22, and we are having C and D. And in the right what should come? 32. That means this part. So 32, 14, E, A and B. Okay, it is like this. Fine. So 22 plus 32, you will get 54. Fine. Now this new internal node would be inserted in minimum heap. Now we'll be having internal node and value is 54. Now you can see the last point. We have to repeat step 2 and 3 until the heap contains only one node. Now the minimum heap contains only one node with the value 54. Now we have to stop this algorithm. Okay, now see, we have got this tree. This is known as Huffman tree. Fine. So this tree is known as Huffman tree. Now what you have to do to all the left nodes, okay, to all the edges which are going left, you have to give value as 0. So this is left child, 32 is right child, then for 14 is left of 32, so here also 0. For A, this is also left, so this will be 0, and all the right child will get the value as 1. So this is D is right child of 22, then this one is also right. Okay, so what you have to do, you have to give zeros to all left edges, and all the right edges should get 1. Now what you have to do, you have to traverse. See, we have discussed that this algorithm works in 2 phases. First is build Huffman tree, which we have already done. Second is traverse Huffman tree and assign codes to the characters. So how do we traverse? See, we have to traverse to each symbol from the root. Okay, so we'll start with the first one. This is C. If you'll traverse from the root C, what code we will get? 0, 0. See the edges, 0, 0. So we'll write it over here. For C, code is 0, 0. For D, traverse it from the root 0, 1. So it will be 0, 1. For A, you have to traverse for each symbol. All these internal node doesn't matter. So you have to traverse for the symbol. All the leaf nodes you have to consider. So for A, if we'll traverse from the root node, see, 1, 0, 0. So for A, code will be 1, 0, 0. For B, code will be 1, 0, 1. Okay, 1, 0, 1. For E, code will be 1, 1. 1, 1. Okay, now you can see that for all the symbols we got the code. Fine. So instead of representing this A, B, C, D, E with ASCII code and then with binary numbers, then with 8 bits or something, instead of representing it in that way, which will take more space, what we can do, we have given certain symbols, certain code for each symbol. Okay, we can use it. You can see from here that the frequency of E was highest. Okay, frequency of E was highest, then D, then C. Okay, and frequency of A and B were low. You can see it over here that for C, D, E, for these three, the code contains only 2 bits. Okay, we are using less number of bits to represent C, D, E because these are occurring more frequently as compared to A and B. And you can see that for A and B we are using 3 bits because these are occurring less frequently. So that is what the concept of Huffman encoding is, that you have to use less number of bits to represent the symbols which are occurring more frequently, and you can use more number of bits to represent the symbols which are occurring less frequently. Okay, I hope you must have understood that how to calculate code for each symbol. Okay, in case of any confusion, you can post your queries in the comment section. Thank you so much.